Have you ever felt lost while working with microservices in Kubernetes, navigating through complex configuration, outdated documentation, and disconnected pipelines? The chaos can slow development and hinder collaboration. Enter Backstage, an open source developer portal that centralizes everything your team needs: service management, up to date documentation, metrics, and streamlined access to essential tools. Backstage turns confusion into clarity, boosts team productivity, and putting developers back in control. Let's dive how it can transform the way it works. Welcome to Cloud Station, and in this session, I will explain the importance to use Backstage in your development flow. This episode kicks off by highlighting the challenges and introducing Backstage as the solution, a platform that centralizes service discovery, documentation, and tooling in one place. I will set the stage by exploring why a tool like Backstage has become essential in modern software development workflows. Backstage is an open source developer portal designed to bring order to the chaos of managing microservices, especially in Kubernetes environments. Many teams struggle with complex documentation, inconsistent tools, and a lack of visibility across their services, leading to inefficiencies and frustrations. When to use Backstage probably is the question. Okay, let me give you 4 important points according with my experience that probably Backstage could be useful for you, or your company, your projects itself. Backstage shines in environments where managing microservices feels overwhelming or inefficient. It is especially useful for the following points. First one, teams with multiple microservices. When tracking services, owners, and dependencies become a challenge. Pay attention about that, because sometimes when you have 3 microservices could be probably easy to maintain. But what happens when you have 20, 30 microservices with different dependencies, with different trackings, with different owners? So you need to centralize this in order that probably maintain better, and of course give the visibility that the project needs. Number 2, organization with a silo knowledge. If documentation, configuration, or best practices are complex, Backstage centralizes all them for easy access. Number 3, the need for consistency and standardization. Backstage helps enforce consistent tooling, templates, and workflow across teams. It is probably the most beautiful feature that I love from Backstage, because when you are working with different microservices, with different programming languages, huge teams with different mindsets, you need to standardize teams. You need to put into the plate the best practices that, for example, if you are right now a principal engineer, a tech lead, or you are leading teams, you need to specify the best practices that the project needs to follow, because it's not probably it's not good that the team B use one practice and the team C use another practice or other practice. The idea is use best practices for all the team. Probably is your case. So when you have Backstage, you can specify, okay, and we will use the same workflow for all the projects. We will use the same templates. It is amazing feature, templates, because you can specify all the structure, all the folders that, for example, a Spring Boot application has, or Node.js, Next.js application has. You can specify, or you can structure all the folders, all the directories that your application needs when one project is created in the first time, and you can save time because the people don't need to reinvent the wheel. You have all specified into the templates. The people go with a couple of clicks. Backstage creates the folders, the structure of project for you, and the people can start to code immediately. Lastly, of course, it is very important too, Kubernetes heavy workflows. Kubernetes itself is not easy. I know that sometimes it is a nightmare for beginners people, or probably people that is not don't feel comfortable working with microservices, cloud itself. But with Backstage, you can probably create a flexible or maybe a more interesting experience to this kind of developers or this kind of people in order to use Kubernetes. How? Backstage simplifies the discovery and management of Kubernetes resources, integrates with continuous integration and continuous deployment pipelines, and support monitoring tools. So it means you can have into Backstage, for example, what is happening with the different merge requests or pull requests. So you can centralize all the operation or the workflows in one place. In addition, you can integrate Backstage with tools like Prometheus, Grafana, for example, and developers only needs to have access to Backstage in order to see the things. So again, when you have different tools, different dependencies, you need to access for all individual applications. With Backstage, you can centralize this information in one place, and you probably can maintain the access easier than has different tools everywhere. So by centralizing information and tools, Backstage boosts productivity and helps teams focus on delivering value, not managing complexity. It is probably the most important thing when to use Backstage. When you want to deliver value and not be aware or probably concerned, I think so the adequate word, not concerned managing complexity. Key concept of Backstage. Backstage offers several powerful components designed to simplify and enhance the developer experience. But I created this couple of points, probably we can extend later, but for me, 4 important components of Backstage. First, software catalog, a centralized directory for all your services, libraries, and tools. It enables teams to easily discover, manage, and maintain ownership of services. Integrated tagging and search feature make it simple to find the resources you need. Number 2, tech docs. A good project has good documentation, right? Okay. A documentation platform that ensures up-to-date centralized and version control documentation. In other words, you can have into your code, you can create markdowns markdown format files in order to document your project. It reduces the time spent searching for complex information. So, tech docs build on Markdown and integrate seamlessly with your source control. So regularly, I know that there are different tools in order to create documentation, probably better than Markdown. Of course, totally agree. But for example, the basic case when you're using README files is very common, right? So you can have all your documentation in one place, and you can use the tech docs feature from Backstage, and this feature will look into all your Markdown files and create the documentation for you into Backstage, and probably the user, you will see more user-friendly, use all the features that probably Backstage has to offer in order to interpret the Markdown or convert the Markdown file into user-friendly web pages, for example. So tech docs can help us, and the good point is that if you put this into one specifically source control version or versioning like GitHub, GitLab, so you can continue creating files, and tech docs automatically will refresh and updating the documentation for you. So all is good. Third point, it is about the plugins. You can extend Backstage. Extend Backstage functionality with integration for CI, CD, monitoring, and more. It is good. Imagine that it is like a Lego where you can put different parts and you can build your empire or your building like you want. Popular examples include plugins for Kubernetes management, Prometheus metrics, and GitHub actions. Custom plugins can be built to address team specific needs. Last one, it is scaffolder. Automate service creation with predefined templates. I mentioned this in the first point, but I want to mark this again. So you can automate how you create a services or microservices using predefined templates. Scaffolder ensures new microservices follow best practices and team standards. Imagine that you have projects in Golang, projects in Python, project in Spring Boot, and you need to specify, okay, I want a template that follow the teams and best practices and the team standards and the best practices, and we already know what is the practices that this project needs to follow. Okay, that's it. You can create a template with all the scaffolding, and the scaffolder will create it for you with a couple of clicks. Saves time, of course, saves time. You can save time while maintaining consistency across projects. Each component works together to centralize and simplify workflows, making Backstage a hub for managing the complexities of microservices and Kubernetes. Okay, it is about the theory. In the next, in the next session, probably, okay, it is about the theory. Let me show you how you can create probably a local Backstage and you can start to use it. Backstage provides tooling to build Docker images, but can be deployed with or without Docker on many different infrastructures. The best way to deploy Backstage is in the same way you deploy other software at your organization. And Spotify, they deploy software generally by building a Docker image, storing the Docker image on a container registry, referencing the image in a Kubernetes deployment YAML, and of course applying this deployment to a Kubernetes cluster. Some prerequisites, of course, probably you feel comfortable using terminals, or you have a Linux or Mac or Windows subsystem. So my recommendation is regularly use Linux, but if you prefer to use another operating system, it's good too. In addition, important to have a environment available with the command line that you prefer. For example, on Debian Ubuntu, you will want to have the make and build essential package installed. On Mac OS, you will want to have run Xcode select installed to get the Xcode command line build tooling in place. Of course, to use curl or another ways in order to download packages, of course, depend on your operating system. Backstage use Node.js, TypeScript. It is behind the scenes. Backstage is a React app using TypeScript, so you need to be familiar with Node.js. The recommendation is to use Node.js active LTF release, install it using different methods like npm, for example, is recommended. Install it npm or install and change Node version with npm. Have yarn command in order to manage all the different tasks into the project, Docker installation, of course, and Git installation. The demo, so it's easy. To install Backstage standalone app, you will make use of npx. It's a good tooling. npx is a tool that comes pre-installed with Node.js and lets run on commands straight from npm or other registries. Before we jump into running this command, and let's chat about what it does. For example, we run this command and see what is happening. So here, the first question that I can see is the name of the app, for example. So in other words, when you start to use Backstage, you can't create your Backstage standalone app in your local. Because again, remember, the idea behind of scenes with Backstage is that you can extend, or you can create your custom teams for your project or for your organization. So in this case, let me, for example, Cloud Station example. I already have one project created, but I want to explain you the step-by-step with this example. You can see that with this command, you can't or npx create for you all the scale folder, all the different files, and probably take a couple of time in order that solve the things. In the meantime, let me explain you another important folders that NPX create for you. For example, general folder structure below is simplified layout of files or folders generated when creating an app. It is the name of your app, and you probably will see app config, main configuration file for the app, see configuration for more information. You can go to read this into the official Backstage web page. The catalog info YAML is responsible for managing catalog entities descriptors. So package.json, of course, it is the root package.json for the project. Be sure that you don't add any npm dependencies here, as they probably should be installed in intended workspace rather than in the root. In other words, this package.json, please keep simple. And if you want to add another dependency for your project, go into the package itself and install the dependency itself. Packages, we're using Lerna. Everything here is going to be a separate package managed by Lerna. Package/app and functioning Backstage frontend app that acts a good starting point for you get to know Backstage. Backstage backend, of course, we include a backend, and this helps power features such as authentication, software catalog, and other things. So if you will see this, right now we are ready to use Backstage. Remember the name of this app was CS example. So it means that if we go into the directory, you will see all the different features about that. We can run this, ls. So you will see all the different files that I explained. It is in the documentation. And you can run yarn dev in order to see the project working. So if you see that, open a browser for you, and you can see, or you will see, the user interface. Right now, the sign in and login is disabled by default, but you can specify, for example, providers. You can go to settings and specify authentication provider, feature flags, and other things. So here you can start to see probably the most important things about Backstage. You have the home. In the home, you can see the components or the kind of resources that you can create in Backstage. For example, the API, you will see that you have system owner. It's good because the owner means that who is responsible, or who is the owner, of course, about this component. So you can have DevOps team, you can have developers, team names, or you can have team's name, for example, I don't know, developers, QA, and so on. It's good. You can specify different things there. Components, groups, location, template. So good. You can create a template too, or you can use a template by default. For example, here, if you see all the information about the template itself, we can create a template too, and so you will see the format of template. For example, it is a template in order to create a Node.js app. You can choose this, put the name. You can specify the owner, the organization, the user or project that will belong to, for example, owner DevOps, or the owner that you created into Backstage, and the repository itself, in this case, github.com. And with that, if you click review, and all is good configured in Backstage, Backstage will create all the structure, all the scaffolder for a simple Node.js service in your repository. It is the magic. It is probably a good feature that the most of the people, the most of the teams use Backstage, because you can create services, microservices, a couple of clicks, and that's it. You have all the structure and the folders created for you. So you can continue exploring about that. You can see the different components, probably the website. You can see information here. You can see, for example, you have a project created. You can add the continuous integration, deployment, and dependency, of course, tech docs, all the documentation that you can't probably has a one place in order that the people can read what is the documents, or explained what is the idea with the project. In other words, you can have the docs there. The people can read all the details about that. You can see the relations, you can see who is the owner, the system that belongs, website, life cycle, on different links and subcomponents. So of course, it is, and this video is introduction. We can continue creating more things in other episodes, but for the moment, it is the simple visualization that you can get there. So what happens if you have this ready, you want to move this or to deploy this in Kubernetes? The next step, of course, is to create a build image, or Docker build image. So let us move forward to do it. There are 3 ways to build a Backstage app into a deployable Docker image. First, it is the host build approach, which is recommended due to its speed and more efficient and often simpler caching. The second way is a full multi-stage Docker build, and the last way is to deploy the front end and back end and separate image. Depend on your needs, depend your context, you can't choose the best way for you. Something that goes for all of these Docker deployment strategies is that they are stateless. It means that you need to store a persistent volume, probably, or database, external database, in order to persist all the plugins and all the data from Backstage. So for production deployment, you will want to set up and connect to an external PostgreSDB instance where the backend plugins can store their state rather than using SQLite. By default, when you are working local, if you don't specify a PostgreSQL database, Backstage will use SQLite. Of course, can be useful for local, but if you, of course, move to development side or whatever, another environment on cloud, QA or production, of course, you need to persist the data in one place, and the recommendation is PostgreSQL instance. This section assumes that we have right now an app. This app has already been created with the Backstage create app command, in which the front end is a bundle and served from the backend. So Backstage use the backend in order to serve the front end and build all the bundle and serve this in order to be used. This done using the plugin at backend, which also injects the front end configuration into the app. This means that you only need to build and deploy a single container in a minimal setup of Backstage. So let me get started with example. The first command is the yarn immutable. Let me go to the Backstage application. So if we want to create all these types from TypeScript in our repo root, we need to run the yarn TCS. It's important too, because sometimes if you need to transpiling things with TypeScript, you need to create the types. Okay, all right. So next step, we need to build the backend. Again, which bundles it all up into the package backend this folder. Using the yarn build backend and specify the config files, we can create all the bundle, included the app and the backend, and the backend will serve a front end for us. So probably if you have experience working with multiple configurations, you can understand this, but if not, no problem. Let me explain you. So with this command, we are passing the different configuration to Backstage, right? It is a probably minimal strategy that regularly Backstage use. If we go to the configuration, we can see the app config files and local config and config production. What means, for example, add config? It is the default values that Backstage will use in order to configure all the stuff related to it. So it means that all the default values that you need to put into the Backstage, you will specify them into this file. But if you have different environments and you want to override them using environments, you can only create, of course, app-config the name of the environment. In this case, production, development, QA, and so on. With this strategy, for example, there we are using only local things, but for example, I am using for default value, the connection to the database is better SQLite tree, but in production, we are using PostgreSDB with all the configuration. When we run this command, what is happening behind the scenes? It means that Backstage will use this value by default, and this one will overwrite all the files that matching with the app config. So the first one is default values, and the last one overwrite the values that match between files. It means that, for example, in this case, we are using better SQLite tree, but here Backstage will be overridden using the database PostgreSDB, because it is the last command or the last configuration that we are passing. Okay, let me run this. Of course, I want to delete this type, the distribution files in both sides, in order to see what is the result of this command, of course. Copy that. Okay, excellent. Boom. We need to wait a little bit. We are able to see that it is building up separately because it is a bundled package. And so this type, this folder for app, and of course this folder for backend. So all is good right now. The next step, of course, once the host build is complete, we are ready to build our image. The backend side is responsible for serving the front-end application, the front-end files. So we only need one Docker file because we are creating a bundle, and the bundle is created from backend. So if we go to the backend side, we will see that we have our Docker file, and we of course this Docker file needs to be executed with the root of the repo as the build context in order to get access to the root, yarn, lock, and package.json, along with any other files that might be needed, such as npmrc. Okay, got it. So here we are creating, or we are building a Docker image, like probably you have experience. Docker image build package, the backend, the name of the image. We're using the latest version. Waiting a little bit, that is being created. And so if you want to use this out of course, your computer or in Kubernetes, you need to push this image to, I don't know, whatever container registry that you prefer. Okay, that's it. Docker created the image. It's good. And the last step is to run the Docker Compose YAML, where I am using a Postgres database. I am passing the environments, PostgreSDB, because I am using the configuration for production, and the image. So let me run the Docker Compose app, creating the things, get the database, and we'll create the container image too. So if we run a browser, probably we can see our Backstage. So let me show you the example. Yep, right now you can see the guest and GitHub. I modify my Backstage sign-in page in order that accept GitHub, but of course I can explain later. But for the moment, you have the chance to log in like guest, enter. Right now, you are able, right, to navigate in Backstage using a Docker image. So we are right now ready to move to Kubernetes and deploy this in Kubernetes. But probably you right now understanding what is the approach, we need to create a service, a deployment, and probably will work. Of course, if right now your Docker Compose is working, you see that your Backstage and database is communicating each other, and probably the next step is, okay, I want to orchestrate my containers using Kubernetes. It's de facto, of course, totally understandable. So you can have different options in order to test this locally. For example, you can use Minikube, you can use Kind or Key3s. Depends on your experience, depends on what you are looking for. This kind of technologies could be useful for test your Backstage instances locally. So you can choose whatever you want. In this web page or the documentation of Backstage, they are recommending to use Minikube, but again, you can use another one. The important is that, or probably the main prerequisite is has a Kubernetes cluster working in your computer, right? So you can check that your Kubernetes is working, probably executing the kubectl get pods in order to see what is happening, and that's it. You can stop, of course, the Kubernetes instance using Minikube, using the command minikube stop. The recommendation is, of course, in order to insulate the component related to Backstage is by using a namespace, specifically to put all the Backstage resources in one place. In this case, we are creating a namespace named Backstage with the idea to put all the resources that Backstage will need in order to work. So you can create this, of course, using the command, so probably using the YAML, whatever strategy that you want. So the next step is to create the Postgres SQL database. Backstage in production use Postgres SQL as a database. To insulate the database from Backstage app deployment, we can create a separate Backstage deployment for Postgres SQL, of course. So the first is create a Kubernetes secret for the Postgres SQL username and password. This will be used by both the Postgres SQL database and, of course, the Backstage deployment. So here we are creating the user and password. And of course, if we want to see the data, remember that the secret are base 64 encoded. So the values can be generated on the command line. Use the following strategy. So you can apply the secrets, and right now you have the secrets about the Postgres SQL information that you will need for the instance and for the Backstage deployment. The next step is to create the persistent volume for Postgres SQL. So right now we are creating here the persistent volume, and of course we are creating the claim itself. So for this demo, of course, this locally you are using the host path and probably you are taking advantage about the disk of your computer, but in production the recommendation is to use another more extensible or elastic functionalities. For example, EBS from AWS could be useful for you because you can take advantage about snapshot and other features that EBS offers. So again, you can create storage classes pointing to this kind of functionalities and has more persistent resiliency storage for your instance. Again, for local, it's enough working with your disk, but pay attention when you are creating the different resources in cloud, because it's not a good practice store the data in the disk of the node. The idea is to take advantage about more elastic functionalities on cloud itself. So here again, we are creating the persistent volume, a persistent volume claim. The next step is to create a deployment for Postgres SQL deployment. We're specifying the namespace, the replicas, the image, and of course we are mounting the claim that we created in the previous step. So when we have the deployment, the secret for the Postgres SQL instance, the next step is to create a service. Of course, we need to expose these pods, these Postgres SQL pods. We need to expose them because, for example, the Backstage deployment will try to access these pods. So the only way in order to communicate between each pod, for example, is using, of course, services. Is a good strategy in order to avoid You can use, of course, another strategies communicating pods directly, but if you probably want to avoid the nightmare to manage pods IPs when one pod died, of course, probably you can think the best option is to use services. So we're creating the service. The selectors is pointing to the recently deployment Postgres SQL deployment file. So here the service will be aware of all the pods related with the Postgres SQL thanks to the app selector that we're specifying. We apply the services and that's it. The last step is to create, of course, the Backstage instance. Again, you can create a secret if you have sensitive data, for example, the GitHub token and other stuff that probably your Backstage will use, like environment variables. In this case, we are the resource or this documentation is assuming that you are using GitHub token, but probably you can use GitLab token and other stuff that probably you don't want to put directly or hard code directly into the deployment YAML. Okay, again, you can follow the best practice of Kubernetes, taking advantage about the config maps and secrets and trying to configure appropriately without hard code this information into the deployment files. Creating a Backstage deployment, so easy. Probably if you have experience with Kubernetes, it's only create a deployment and probably the only change is to specify your Backstage instance that you need to push into whatever container registry that you want, and you can specify here. If you are using Docker, probably will be Docker Hub, and you can specify your container image here in order to create, of course, the Backstage deployment. And that's it. After that, you can create the different things. Your Backstage is right now taking advantage about the different functionalities, and of course, you can use all the different stuff that Backstage offers. In this case, of course, for production deployment, the image reference will usually be a full URL to a repository on container registry, for example, ECR on AWS. For testing locally with Minikube, you can point the local Docker daemon to be Minikube internal Docker registry and then rebuild the image to install it. So it is you can use this strategy. Probably constantly your local Docker daemon could be the registry if you want to constantly building the image because you are applying changes. So here mention that there is no special wiring needed to access the PostgreSQL. Since it is running on the same cluster, Kubernetes will inject Postgres service host and Postgres service port environment variables into a Backstage container. And this can be used in the Backstage app config along with the secrets. Apply this app config production YAML as well if you have one, for example. And that's it. You can apply. You can see what is happening. All the pods running, all the namespace running, the services. You can see the logs. Again, if you want to expose like the PostgreSQL service, you can expose the Backstage service. You can create a service for the Backstage, and that's it. Could be work without any problem. So note that app base URL, backend base URL in your app config YAML should match what we're following here about the port omitted in the example, since we are using the default HTTP port 80. So again, you can continue improving different things. Probably the persistent volume could be a good strategy. You can update the deployment image, and so you have different options to improve, but this example is only for works locally. And when you see that all your Backstage is working locally, you can think another strategy to move a cloud, but probably the changes on cloud is more related to infrastructure. For example, again, the persistent volume using a storage class appropriately. You can point into one specifically container registry. If you're using Docker Hub, ECR, whatever that your company are using, you can continue improving and hardening this example, but the most complex task is ready, that it is to apply the different changes in the code for Backstage, and of course create the continuous integration, continuous deployment related with your changes. For example, in the continuous integration, you can create or build your image In the deployment, you can use GitOps or another strategy to deploy the changes into Kubernetes. So that's all. I hope that you can enjoy Backstage. Being honest, Backstage is a great technology, very useful technology that right now is improving and speed up the deployment and development process to different teams. And why not? You can collaborate with features in the community and trying to create amazing teams. So that's it. Thank you so much. Don't forget to follow and comment. Appreciate the feedback, and we will try to continue creating content in order that could be useful for you. Take care, guys.